Reverb is a sound continuing through the reflection of off surfaces, like echoes and tails of sound from reflective surfaces. These tails bouncing off these surfaces become quieter and quieter. This is known as a decay. Adding reverb to a track gives us a sense of space, which is especially useful if the space was taken out of the recording and we need to add it back in. This stimulating the impulse response that is applied to the sound signal to create the reverb effect on that sound signal. Convolution reverb is taken from real rooms using multiple microphones to capture or sample the acoustics of a room, capturing the complexities of real space. Then the sound you make is filtered through the impulse response generator to create an effect as if your sound was recorded in that room. Convolution reverb is more like a sampler used from recorded sound, while algorithmic reverb is more like a digital synthesizer, creating the effects of space through a formula. Convolution using this filtering and mixing can have a larger impact on CPU in comparison to algorithmic reverb, so in this case it's advisable to use over multiple tracks or as few as possible single tracks. Convolution reverb can also capture more real complexities of acoustics in a way that algorithmic cannot quite generate. The impulse response file of a convolution reverb as it is applied from a room tends to not be very flexible, while with algorithmic reverb, the algorithms are adding the reverb so you can change the parameters more. So while it may not be as complex as convolution reverb, algorithmic reverb has more control. The convolution reverb can also be useful to add more realness to instruments. So instruments that aren't samples that have some natural noise. So we can look at the convolution reverb first. Bring the volume up. So we'll try taking a look at each one of these individually. Here's a sample of the bass track. A convolution reverb. A convolution reverb is a reverb based on mathematical processes of convolution. It takes an impulse response, or IR, a sample from a real-world space, and uses this to digitally simulate the reverberation of that space. Only a convolution reverb can capture the ambience of a real space or real hardware and recreate it on a computer. With convolution reverb, you can easily access the reverb of many spaces and still tweak them. Reverb effect. The input signal passes first through high and low cut filters, whose XY controller allows changing the band's center frequency, X-axis, and the bandwidth on the Y-axis. Either filter may be switched off when not needed to save CPU power. Pre-delay controls the delay time in milliseconds before the onset of the first early reflection. Pre-delay controls the delay time in milliseconds before the onset of the first early reflection. This delays the reverberation relevant to the input signal. One's impression of the size of a real room depends partly on this delay. Typical values for natural sound range from 1 millisecond to 25 milliseconds. Early reflections. These are the earliest echoes that you hear after they bounce off a room's walls, before the onset of the diffused reverberation tail. Their amplitude and distribution gives an impression of the room's character. The shape control scopes the prominence of early reflections as well as their overlap with the diffused sound. With small values, the reflections decay more gradually and the diffused sound occurs sooner, leading to a larger overlap between these components. With large values, the reflections decay more rapidly and the diffuse onset occurs later. A higher value can sometimes improve the source's intelligibility while a lower value may give a smoother decay.